Morning students. Today we shall discuss the important theorems. Cauchy's integral formula. First theorem. Cauchy's integral formula. Cauchy's integral formula. Statement: if f of z is analytic, if f of z is analytic inside and on C, on a curve C with z equal to a, is any point in C, z equal to a is any point in C, any point in the circle or curve C, then f of z equal to, or f of z equal to a is equal to 1 divided by 2 pi r integration C f of z dz. Then now proof modify. F of a is equal to 1 divided by 2 pi integration C f of z dz. Here also taking f of z, one term z minus a divided by z minus a dz. This is the integral C. Given f of z is analytic function inside and on the curve or circle C with center z equal to a is any point in the C. Z equal to a is the any point in the circle C. Write the circle C, the one circle or curve. This is another curve. This curve is C, this curve is C1. Z is any point and Z equal to A. Z is equal to A is a point. Next proof. Since A is any point, A is any point in C, the circle C1 inside the C, inside the C, then inside the C with z equal to a is center and r is radius of C, radius of circle C, or first circle, this is the radius, or circle C1, also C. Next, by using Cauchy's by using corollary 1. By using corollary 1, integration C f of z dz is equal to integration C1 f of z dz are equal, equating the two circles C and C1 are equal. Next, integration C f of z divided by z minus a dz, taking the z minus a 1 divided by z minus a both sides, is equal to integration C1 f of z divided by z minus a dz. This is equal to integration, here integration C1 f of z, here f of z equal to, taking the equations like that, z minus a, modulus of z minus a is equal to r, is the equation of a circle whose center is a and r is radius. Equation of a circle, center a and radius is r idaga, modulus of z minus a equal to r is the equation of a circle. Equation of circle. Then taking the z minus a is equal to r e raised to I theta is polar form of the equation. Z equal to a plus r e raised to I theta. It comes this side. Okay. dz equal to a is 0. Differentiating r e raised to I theta is I into e raised to I theta d theta dz. Okay, fill up in this equation. These are the solutions of this equation. Fill up this equation. Integration C1 f of z equal to z equal to this term, f of z equal to a plus r e raised to I theta, this is the z term, divided by z minus a equal to r e raised to I theta, this term. Next, dz equal to r I e raised to I theta d theta. Okay, this is the C1 circle. C1 r e raised to I theta cancels. Here r e raised to I theta is equal to, take I outside, integration C1 a plus r e raised to I theta d theta is the remaining terms. Next, this is true. This is true. R is greater than 0. This is true. R is greater than 0. However small, r tends to 0. R tends to 0. Then the terms r tends to 0 means this term is tending to 0. Remaining term is equal to I integration C1. Here this term is 0 means f of, here also f of a is term, this is 0 d theta. This implies, this is also written as I f of a, taking outside, integration C1 is a circle 0 to 2 pi 1 into d theta or d theta. This is also written as I into f of a as it is. Integration of 1 d theta is theta in the interval 0 to 2 pi. This implies I into f of a upper integral 2 pi minus 0. This implies f of a into 2 pi I is the term. Next, in the LHS side is this integration C f of z divided by z minus a dz. This is the LHS side equal to RHS side is equal to f of a into 2 pi r. This is the solution. Next, taking 2 pi this side, f of a is equal to, this is multiplication term, coming to this divide 2 pi I integration c f of z divided by z minus a dz. This is the Cauchy's, this formula is called Cauchy's integral formula. This is called Cauchy's integral formula. This is called Cauchy's integral formula. This is important for the solution of another theorem. This statement or this solution is important. Next one, Cauchy's integral formula for nth derivative. Next theorem is Cauchy's integral formula for nth derivative. Cauchy's integral formula for nth derivative. Derivative or derivatives. This is important 5 mark statement. If f of z is analytic, f of z is analytic inside and on C, on the circle C, on the circle C, and A be any point and A be any point in C, any point within C. Within C means C ನಲ್ಲಿ C ಒಳಗಡೆ ಇರುವಂತ ಒಂದು ಪಾಯಿಂಟ್. Next, then Fn of A is equal to Fn of A is equal to n factorial divided by 2 pi I integration C f of z divided by z minus a raised to n plus 1 dz. Proof ಮಾಡಬೇಕಾದ್ದು nth derivative fn of a is equal to n factorial divided by 2 pi integration c f of z divided by z minus a raised to n plus 1 dz. Here also given f of z is analytic function inside on the boundary C. A is any point within C, within the circle C. Proof: Now by using Cauchy's integral formula. Already solved this statement. Cauchy's integral formula, that is f of a is equal to 1 divided by 2 pi I integration c f of z divided by z minus a dz. This is called the Cauchy's integral formula, also in equation number 1. Applying Leibniz rule, Leibniz rule, differentiate under integral sign. Then f dash of a integration under the differentiation integral sign f dash of a to differentiation 1 divided by 2 pi I as it is integration c f of z dou by dou a with respect to a 1 divided by z minus a dz, z minus a dz. Next, this is equal to 1 divided by 2 pi I integration c f of z, also written as dou by dou a of z minus a raised to minus 1 dz is equal to 1 divided by 2 pi I integration c f of z as it is differentiate this term with respect to a is, this is the form of d1 dx x raised to n is equal to n into x raised to n minus 1 differentiation. This using this formula. Suppose using this formula, n means minus 1, x raised to n minus 1 means z minus a raised to n is minus 1, already in the formula minus 1 with respect to a differentiation. A is 1, taking minus 1, so minus a dz. This is equal to 1 divided by 2 pi integration c minus into minus plus 1 f of z into z minus a minus 1 minus 1 minus 2 dz. It's also written as 1 divided by 2 pi I integration c f of z 1 divided by or f of z divided by z minus a, taking this is denominator minus 2 dz is equation number 2. Is 2. This is the f dash of a. F dash of a. Next, again differentiate this in. Again differentiate f dash of a means equation 2 with respect to a. Again differentiate with respect to a. Again differentiate or differentiation with respect to a. Take f dash of a differentiation is f double dash of a is equal to this term 1 divided by 2 pi integration c f of z. This is taken the numerator z minus a raised to minus 2 dz. This is equal to 1 divided by 2 pi I integration c f of z dou by dou a of z minus a raised to minus 2 dz. Okay. Next, this is also equal to 1 divided by 2 pi integration c f of z as it is dou by dou a of z minus a raised to minus 2. This is also here also using this formula d by dx of x raised to n is equal to this formula. Next, n means minus 2 into z minus a raised to minus 2 minus 1 with respect to a is minus 1 into dz is equal to 1 divided by 2 pi I integration c f of z as it is minus 2 minus 1 2 z minus a raised to minus 3 dz is equal to 1 divided by 2 pi I integration c, taking the 2 this side outside integration c f of z divided by z minus a raised to 3 dz is equation number 3. Is equation number 3. Continuing this way, we get fn of a. This is the f double dash of a. f n of a or nth term is equal to 1, 2, 3, so n factorial divided by 2 pi I integration c f of z divided by z minus a raised to n plus 1 dz is the nth term fn of a. This is the nth derivative. This is called Cauchy's formula, Cauchy's integral formula for nth derivative, or derivatives. This is the important theorem for the examination. Thank you.